Good morning, sir.
Very good morning, everyone. Very good morning, Harsim.
Good morning, sir.
Very good morning. Welcome, everyone. Very good morning. Welcome to the class. I hope everyone is ready to start your journey with air navigation. Good morning, Sauradip. Welcome to the class, your first ever live session.
Good morning, sir. How are you
Very
doing?
good morning. I am fine. Thank you. How are you?
I'm good, sir.
Great, great, great. Rishi, good morning. Jyotsna, good morning. Mohammed Azam.
Good morning, sir.
Very
Good morning, sir.
Very, very good morning, everyone. Let's just settle down. We'll begin in a minute or two. Okay. It is helpful if you make your own notes. So I would suggest you make a separate notebook for your navigation. And we'll keep this book till the time you clear your exams. So I can see Harsim. Very nice to see you, Harsim. Students, whoever can keep your videos on, please keep it on. Students who cannot keep it on, it's fine. Anshul, welcome to the class. Very good morning. Very happy to see everyone on time. Rishi is there. Everybody just check your readability with me, okay? Everybody can hear me on a scale of 5. That is perfectly readable. Anyone who cannot hear me, just let me know.
Perfectly readable, sir. On a scale of 5, it's 5.
Thank you. Very good morning, Neha. Thank you, Sauradip. 1, 2, 3, 4, 5, 6, 7, 8. Great. Okay. So I think Lakshya is not here. Vivek Yadav is not here. Swamini, Manoj Rishi, Rajat, and Utkarsh. Fine. Okay. So before we start, okay, let me just check with these guys and girls if they are joining. Okay, because this is the first session. Let's see. Until then, I have a question for everyone to think. A question to ponder. Okay. Now, the question is very simple. It's a similar question that I ask before I or when I take the first class for any subject. And the question is, what do you think is air navigation all about? Okay, so start thinking about it. What is air navigation to you? Now, students who have had some amount of training in air navigation, you already know what it is, but still try to frame. How would you frame this answer to the question, what is air navigation? Students who don't know anything, students who are starting for the first time, I'll be highly curious to know what is your understanding of air navigation. And why do you think it is one of the most important topics for us to study? And why do you think it's considered to be the most difficult topics to study? Right, everybody? So just think about it. So if I have to ask this question, let's say, Rishi, the question, how would you answer? Go ahead, Rishi. Victor Tango Romeo in the mic. Yeah, Rishi, can you give me a verbal answer if possible? Rishi, I've got a text from you. I cannot hear you. I'll wait for you. Hardik, why don't you go ahead and tell me, what do you think is navigation all about? What is navigation in your terms?
Sir, maybe same as we navigate in cars, like going from one place to another and knowing the routes, etc.
Going from one place to another and knowing the routes, as in knowing how to go there. Okay, very good. Sounds perfectly in sync with what navigation in aviation is all about. It is obviously knowing how to go from point A to point B, or your departure to your destination. Very nice. Harsim, same question.
Sir, navigation is all about going from one place to another.
Navigation is all about
Going from one place to another.
going from one place to another. Okay. Sounds right. Anything else you want to add, Harsim?
No, sir. Negative.
Right. Going from one place to another. Right. Just like Hardik said, navigation is all about going from one place to another. Achal and Jyotsna, let me know your answers in the chat box. What do you think is navigation? Neha, tell me.
We can say determining the position of an aircraft with respect to maintaining the desired route.
Determining the position of an aircraft with respect to the route. Right. It is very important that the pilot knows his or her own position or the position of the aircraft. It could be with respect to the route. It could be with respect to any reference that we have. Very well said. So knowing how to go from one point to another through routes, determining your position. Very well said. I have answer from Jyotsna in the chat box. Guiding the aircraft to fly from one point to another. Guiding the aircraft, that is very important. So you are guiding the aircraft to fly from one point to another. How do you guide? You guide with the help of certain references. Like Hardik is saying, we need to know the road when we are driving a car. We need to know which road to take to reach from one point to another. So that's how you guide the car. And obviously, you also make sure that the car is safe. In navigation, safety is also very important. So I'm checking the answer given by Achal. About planning the movement of the aircraft, that is the routes to be followed while airborne, and also knowing the pinpoint position when in air. Yes, navigation does not only have students, your guidance of the aircraft from point to point, but also the planning part of it. Planning as well as checking your routes and definitely knowing the aircraft's exact location, pinpoint location or the exact location. We call it a position fix. Well said, Achal. Everybody is giving me good answers. So you have good understanding about navigation. Saurdeep has mentioned navigation teaches us about various instruments that are available in the cockpit. That's available. Teaches us how to find our placement in the Earth grid. Navigation definitely is done with the help of instruments in the cockpit. And where is our position with the help of the grid? Earth grid, as in, I think I understand what Saurdeep is trying to say is pinpointing your location with the help of charts. Grids is a form of projection or charts. Okay, so it's like we narrow down the location on the earth in terms of latitude and longitudes or meridians to pinpoint one location up to a high accuracy of a few meters. We'll talk about all this. We have an answer from Rishi also. Rishi is saying air navigation is navigation while flying, so we can navigate our aircraft throughout and be aware of mountains and obstacles. Yes, we have to navigate our aircraft throughout and be aware of any obstacles. If you are sticking to the planned path that everybody is saying, guiding from point A to point B, if you're sticking to a planned path, and if your planned path is free from all obstacles, and if you're sticking to that path, then you are a successful navigator. Very well said, everyone. Mohammad Azam, please share your inputs. Victor Tango Alpha Mike Echo, correction, Victor Tango Alpha Mike Alpha. And Saurdeep, why don't you assign yourself a registration 5-letter code? First 2 letter codes will be Victor Tango VT and any 3 letters of your choice after that. Any initials or anything you can take.
But how do I do that?
You just rename yourself on the app, go under participants, your participant, click on the option 3 dots. Yes. VT, hyphen, and any three initials of your choice. Anshul, are you trying to join from another device? Just confirm so that I give you permission to enter. Okay, I think yes. Saurabh, let me know if you're finding any difficulty. Anshul, let me know if you can hear me well. Manoj, welcome to the class. How do you read?
I'm good, sir. Thank you.
Okay, Manoj, can you hear me properly?
Yes, sir.
Very
I
good,
can
very
hear you.
good. Manoj, I am asking this question to everyone. First, let me welcome you. Welcome and good morning. I'm asking this question to everyone. Everybody has given me an answer. Mohammad Azam, I'm waiting for your answer. Let me know if you can hear me. Manoj, the question is,
Yes.
what do you think is navigation?
Navigation is where we can find the routes in air while flying or navigate the route where we should.
Complete your answer, Manoj.
While flying an aircraft or helicopter, we can't find like the roads now, sir. We can find by Google Maps only. Through them, we can navigate the point to point where we can go to our destination or reach point.
Exactly. Very nice. You need to know the routes that you're flying from. Like you follow GPS while driving. If you don't know the routes and GPS guides you. Similarly, there are specific routes that guide the aircraft. Manoj, well said. Today we are starting your journey towards learning air navigation. So before I start teaching you about today's topic, that is directions and the velocity triangle, I have to tell you about what navigation is. We all know what is navigation, but
Yes.
if we know that if we know the description of this in simple ways, then we can actually connect it with our topics of learning, and we can understand which topics are important for us as a CPL student. Okay. Today, anything and everything that you're starting to learn is going to be practically applicable when you're flying. Are you following?
Yes, sir.
Everything is applicable. Good. Manoj, I'm keeping you on mute. Okay, you are on mute. Fine. Anytime anybody wants to speak something, ask a doubt, you can raise the hand using emojis in the application. You can wait for me to stop, or you can write your questions in the chat box. Okay. The more questions you ask, the better it is for your understanding. All right. Okay. Before we start, this is the first time and this is the only time when you will not have any base because I have not taught you. So before I start, do we have any questions with respect to navigation? Of course, please go ahead and ask. I'm giving you a couple of minutes to think and to ask. And after that, we are going to start with today's session. Think about it, everyone. Anything and everything with respect to your CPL navigation studies. First thing, if you're talking about duration, so this batch is going to be about fast track completion, but we will not compromise on quality. All right. So if anybody is thinking about, sir, how long it's going to take, we are going to finish it very fast. And how will we do it? I have a strategy which I'll discuss with you all after you have spent 4 to 5 sessions with me. So initial 4 to 5 sessions will be slow. After that, we'll be increasing our pace. Okay. Any other questions anybody has, feel free to ask. Mohammad Azam has just given his answer. Let's just check. General navigation is defined as the process of planning, recording, and controlling the movement of an aircraft from one place to another. Planning, recording, and controlling, right? You have everything is involved. Recording here means that somebody is tracking your flight. That is what I understand from what Mohammad Azam has said. And what was the last word? Recording and controlling. Of course, you have to control. Your aircraft is always under the influence of a lot of air when it is flying. Okay. And the air results into wind. And wind, if it is strong enough, can change the direction of your flight without the pilot realizing. And we don't want that. Okay, we don't want the effect of the wind to change our direction without the knowledge of the pilot. But that is highly possible to happen. This is one of the major issues that you will face as a pilot. And such issues we can say are a part of general navigation. So what is general navigation? General navigation is all about very raw flying. Raw flying as in real flying with just a few basic instruments, without the sophisticated cockpit equipments, without the sophisticated radio navigation instruments. General navigation is at the core of your flight training when you join a flight training school. Initial 150, 200 hours, you will be flying general navigation related flights only. After that, will you be introduced to radio nav systems and all other things that you learn. So we start with general navigation because that's the real art of flying. In olden days, when technology was just starting to emerge in aviation, people only had magnetic compass because ships used to use magnetic compass. And that was the only navigation aid that we had in the aircraft. It is only after a long time that we were able to, utilize different radio-based navigation systems for our navigation and aircraft direction control and everything. Okay. So see if you have any questions. Please try to ask a couple of questions before we go ahead. There's a lot to learn. Step by step, we are going to learn. Harsim, you have been very excited to start navigation. Any questions before we start?
Negative, sir.
Okay. Sardeep, Rishi,
Yes, sir.
Hardik, Muhammad Azam, Achal, Jyotsna, Manoj,
Negative, sir.
Neha,
Negative, sir. No
any
questions.
basic
asked.
level questions?
Negative, sir.
Nothing on your mind. So I think you are sitting with a blank mind right now. Empty mind, is it?
No, sir.
Can think it as clear mind, sir.
Clear mind. Okay. Wordplay. Everybody is very cautious about wordplay. No, sir. No empty mind, but clear mind. Very nice. Actually, good. Good. Not bad. Utkarsh, welcome to the class. How do you read?
Sir, radio 5.
So happy to see you, Utkarsh. Read you 5. I was not expecting you to join. What made you join?
Nah, sir.
Nav, sir. Very good. So Utkarsh,
I just have to do this.
yeah, you will do it definitely. So Utkarsh, a question that I was asking everyone, I'll ask you also before I go ahead. The question is, what do you think is navigation? In simple words. Try to give your answer. We are going to start with today's session after your answer.
Navigation is from A to B place. Yes.
Utkarsh, say again. Read you
Not
too.
transporting, sir.
Yeah. No. It's okay. Whatever you
Sir,
feel. Say again.
So the navigation is to like transport aircraft from A to B place.
Okay. Navigation is
I guess.
transporting the aircraft from A to B. Correct. Almost everybody understands this because most of your answers are common. A to B, A to B, A to B. Great. Remember, students, this is your first lecture. And in order to keep a track of your lectures, recordings, revision access, we are in a batch called Foxtrot 22, F22. Okay, F22 is your batch. 22 stands for the year 22 and Foxtrot stands for the series of batch. Simple, if you're wondering what the codes are in sequence. So you will be following, apart from you, Muhammad Azam, everyone else will be following Foxtrot 22. Okay, lecture 1, lecture 2. These two things should be in your notebook on the top along with the date. And understand this is going to be a fast track batch, but will not compromise on the quality. We are going to learn efficiently with quality, but we are going to cover up sooner than later. Simple as that. Okay. Initial few lectures, I'm going to cover all basic topics, which you'll be practicing and developing strong fundamental skills that will enable us to increase our pace of learning. Initially, I'm not going to put a lot of burden on you, but I'm going to make you practice a lot of things, a lot of numericals belonging to general navigation. So Utkarsh, if you're wondering, we don't have a regular batch. For a couple of weeks, initially, we will have alternate days lectures. After that, we will have at least 4 lectures every week, or minimum 3 lectures, maximum 5 lectures every week, depending upon week to week, what topic we are learning and how is our load. We will not try for 5. We'll at least keep alternate at least 1 day in between somewhere, but that will be fast track only. Okay, everyone? All right. So let's write down a couple of points. Okay. Point number 1. Now this is general. Okay. This is something that is not going to be asked to you in your examinations. But these points are really important for you as a student to know before you start learning about topics. So what is the necessity and scope of learning navigation, or theory as we call it? What is it? Okay. Second point, we will see how to become a good navigator. Okay. How do you think you'll become a good navigator? Being a pilot requires you to become a good navigator. That's the meaning. Okay. If you're good with navigation, you'll never be lost. So there are 2 aspects of becoming a good pilot: being a good navigator and being able to control the aircraft as if the aircraft was an extension of your body. Simple as that. So how do you enable the practice to make the aircraft to be an extension of your body? By going through extensive flight training. And how do you become a good navigator? By learning the theoretical aspects and then applying it in your real flight. Okay. So these 2 questions we are going to answer. Point number 1, I want you to write these points. Okay. What is navigation? This comes under scope. Point number 1, it is the art of guiding. Please write down, everyone. It is the art of guiding an aircraft from one place to another. Almost everyone was able to give me this, sir, guiding the aircraft from one point to another, one point to another, one point to another. Art of guiding an aircraft from one point to another. Always it will involve departure to destination, departure to destination, departure to destination, all the time. Okay, this one point will always be there. What is navigation? Utkarsh, are you able to hear me?
85, sir.
Good. Utkarsh, start making notes. Okay. First thing, we are going to discuss in general for 10-15 minutes what is navigation all about. So, art of guiding an aircraft from one point to another. That is the first definition. Write that down. Navigation is fixing aircraft position in air whenever required. This is also a part of you being a good navigator. Utkarsh, nice to see you. And Harsim, once again, nice to see you. Students, whoever can keep the videos on, please keep it. Utkarsh, I can see you have been working hard. Very happy to see that. आपको देख के मुझे feel हो रहा है you have been working hard. Very nice. Hardik, nice to see you again. I'm yet to recognize you by your face, Hardik. Couple of more. I think I'll not forget you now. Mohammad Azam, nice to see you. Good. Sardeep, nice to see you for the first time. Good. Thank you.
Thank you, sir.
Everyone. Yes. So what is navigation? 2 points covered by you as a group. Very happy to see that. You all said, sir, position in air. You all said, sir, guiding the aircraft from one point to another. Well said. So you already know what is navigation. That is great. Your natural instincts are in the right direction. That's going to help us a lot. And we are going to bank upon that. But there are couple of more points that we'll add so that we understand. And here I'm going to show you the branching out of your syllabus or the topics that you need to study. Now, remember, if you follow this strategy, you are guaranteed to clear your navigation in your first attempt, provided you finish studying everything. Okay, I can guarantee you will clear it. But provided you attend lectures and ask questions and do as I say. Remember that, everyone, okay? If you follow, you will pass. If you don't follow, you will require more time to pass. Simple as that. So third point, a pilot who is a navigator is assisted. So now we are talking about the help you will get as a pilot. So all these instruments and radio navigation systems that you think are very complicated to study are actually there to help you navigate safely, are there to help you travel from point A to point B, and are there to determine a position fix. So you don't have to be scared about them. You have to think about mastering these concepts. That should be the intent. That how soon can I master everything that is going to be assisting me into guiding the aircraft and determining its position. So a pilot who is a navigator is assisted by instruments that indicate, number one, height. In bracket, you will write altimeter. Number two, speed. In bracket, you will write air speed indicator and Mach meter. Number three, direction of aircraft in air. Now this direction of aircraft in air, you'll write bracket, you'll write compass, gyro compass. Okay, compass. When you write compass, write magnetic compass and gyro compass. So what you see from this third point in your definition is the first three important parameters as a navigator or as a pilot. That is determining your height first with the help of altimeter. Second is determining your airspeed, which is through airspeed indicator and a Mach meter. These are instruments, okay? Anything with meter, they measure something or the other. And direction of an aircraft, very important. Today we are going to learn about directions. Direction, however you pronounce it. You need to know the direction of your flight. It is very important. One of the most crucial things and one of the most difficult to understand when you're new to aviation, when you have not flown, but you're learning theory. Okay, but it is not difficult. It is easy. So altimeter and airspeed indicator are air data instruments, which we'll be covering a little later. Okay, but the concepts will be very useful to us when we are learning general navigation. What is general navigation again? I'll describe what is general navigation. Okay, so remember, you write these points, then not just these instruments. Write down point number 4 for this. What is navigation? A pilot, in bracket, you will write navigator, is assisted by, in capital letter, you will write observational instruments. To help determine progress number one, progress of aircraft, and number two, position of aircraft relative to ground. Now, what is this? Progress of aircraft, VOR, DME. Simple. VOR DME can actually help you see your progress with respect to how far are you with respect to a particular point of departure, or how close are you with respect to a particular point of arrival, or how close or far are you with respect to a particular point en route. And DME gives you the distance in nautical miles from that particular point. How far are you? How close are you? And so on. Along with VOR, you can also use ADF, or you can also use VDF. Go one point above, point number 3, where I have written direction. Add one more radio navigation aid after gyro compass, right? VDF, very high frequency direction finder. VDF, in future you will see VDF is also used to find directions. VDF is basically you're calling ATC and you're asking them the magnetic direction to reach a station. So I'm just showing you all these instruments that you'll be mastering. They are all related to these basic points that will help you navigate safely. Talking about observational equipments, progress of aircraft, ADF, VDF, VOR, DME. Okay. Position of aircraft related to ground, right? Artificial horizon, also known as attitude indicator. Turn and bank indicator. Slip indicator. These three are gyro-based instruments. So you'll be learning about what is gyroscope, what are gyroscopic properties, and how these instruments, these are observational instruments. You just look at them and you determine a few things about yourself. Your artificial horizon helps you maintain a straight and level flight, not pitch down, not pitch up. So I'll be teaching you what is pitch up, what is pitch down, what is roll, this is roll, and everything. Turn and bank will show you if your turn is within control or not. So these observational instruments actually help you determine your progress as well as whether the aircraft is within the safe parameters of flight. The aircraft is designed in such a way, students, that it cannot cross the certain limitations of its moments or movements. What are the movements that the aircraft has? Look from the side. The first movement is known as pitching up and pitching down. Nose up, nose down, or pitch up and pitch down. An aircraft, when designed by the manufacturer, and depending upon the engine configuration, which engines, how many engines, passenger configuration, weight loading configuration, will have a minimum and maximum nose up and nose down limitation. If it is 20 degrees, so the aircraft cannot do pitch up more than 20 degrees related to the horizon or horizon, however you call it. So your attitude indicator will help you measure this angle. If your aircraft pitches up beyond the limitation, the aircraft stalls. This is stall. The aircraft falls in air and falls on ground. Okay, that important it is to maintain your pitch up and pitch down. So this is pitch up, pitch down. Nose up, nose down, meaning the same, pitching. Okay. The second motion of the aircraft that you will have to control within certain limits would be roll or bank. Both are the same. Aircraft turning to the right like this or rolling to the left, right, left. This is bank. This bank angle is measured with the horizon, the horizontal. It can be up to 90 degrees, but this is 90 degrees. Do you think the aircraft will be safe? No, this aircraft will not be safe. But this attitude indicator will help you measure up to 85 degrees. So that's the limitation that you will learn when you come across these instruments. So as a pilot, you will not only learn about finding directions in your CPL navigation studies, you'll also learn basics about these instruments. Banking. So attitude horizon will show you this. Turn and bank indicator. Now, what is turn and bank indicator? Whenever you turn, you cannot turn like this in the aircraft. You cannot turn like this in the aircraft. You can do it with the help of this rudder, this like this. But the moment you release rudder, it will come back like this. That's the issue with the aircraft. And you cannot subject this particular thing to a load beyond certain degrees, or else the aircraft will break. So how do pilots turn the aircraft? They first bank the aircraft, and after banking the aircraft turns automatically like this. If I have to go to the right of the screen, a bank initiates a turn. Are you following, everyone? On the left side, if I bank, a bank initiates a turn that side. So to turn, banking is important, and this turn should be controlled. Okay, these turns should be controlled. There is rate 1 degree turn, rate 2 degree turn that you will be learning about. Okay, these turns, Mohammed Azam, I think this evening you will be learning about it. Yes. So these turns should be controlled, that in 1 minute, should you turn 180 degrees, or in 2 minutes, should you turn 180 degrees like this. If your aircraft is not maintaining that turn, then the aircraft slips either outside or inside. That is not good for us. You'll experience everything. When you are doing your flight training, you'll experience everything initially. You'll experience side slip also, slipping also, all errors. After working on your errors, will you be flying smoothly? That's when you will be certified to get your CPL license. Okay. And finally, talking about the slip indicator, turn and bank indicator and the slip indicator are in the same instrument only. So you'll be learning about that. All right. So remember, it is not just that aircraft guiding. So you were right about it. It is not just about guiding the aircraft, but determining the position also, progress also, all three. So Mohammed Azam, when you said recording, it's like tracking the progress of the aircraft. All right. Now, couple of points. In the first class only, I want to understand effect of air and wind on a flying aircraft. Okay. Get this into your systems. I'm going to show you something right now. Now, this aircraft has a nose. Okay. This point is known as the nose of the aircraft. Can everybody see it? Anybody who cannot see it, let me know. This is the nose of the aircraft. Okay. Now, this nose of the aircraft, wherever this nose points is known as the heading of the aircraft. If the nose is pointing towards you, then the heading is towards you. How to measure this heading? This heading will be measured in terms of directions, and all directions are between 0 degrees to 360 degrees. Remember that, okay? Numerical value of directions. Today we'll be learning about directions. This is the heading of the aircraft. So let's say there is no effect of the wind. If there is no wind, then you will be informed that there is nil wind, NIL, nil, zero wind. Okay, nil wind. Initially, when there is no wind, and let's say if I have to fly from here through the screen to you, that is a straight flight. So my heading will be straight and my direction will be straight, and I'll cross the screen by keeping my heading in the direction of flight. Right, everyone? That's how we drive our cars and cycles, bikes and everything, right? Buses, trains and everything. They face, the nose of that is in the direction in which they are traveling. That is true for the aircraft also. only when there is zero wind in air. Remember, when there is any amount of wind, let's say wind is coming from this side, or let's say wind is coming from this side. So this side, right side, is known as starboard side of the aircraft. Right in aviation terms is known as starboard. Left in aviation terms is known as port. P-O-R-T, port. Okay. Starboard and port. Winds coming from starboard will try to push the aircraft like this. Winds coming from port will try to push the aircraft like this. Okay. Winds coming from this side, a little bit of starboard, little bit of near the head of the aircraft, they will also try to push the aircraft this side. Wind coming from the tail and the starboard will also try to push the aircraft on this side. Basically, you are trying to fly straight, but any effect of wind is going to push the aircraft in some other direction. As a pilot, as a good navigator, you are supposed to know what is the effect of the wind and what is the deviation wind is causing you. Deviation from your required direction. That is your route. That is your track. In navigation theory terms, it's known as required track. Okay. So this effect of wind is not good for us. But if you can anticipate the effect of the wind, then if the wind is pushing you like this, and if it is making you travel like this, you will adjust the heading of the aircraft in that opposite direction, like this. So what do I do in general navigation? 40-50% of your general navigation is all about this. Wind is coming from here, it is going to push here. So what do? By the amount that the wind is going to push you, let's say 7 degrees, if you are able to calculate it, why not just move 7 degrees in the opposite direction? So when you move 7 degrees in the opposite direction, the wind effect is such that it cancels out the 7 degrees going to the port, and your aircraft still flies in the direction like this. So we are acting smart. We are fooling the wind. We cannot fight the wind. We can adjust ourselves. So it is not always compulsory that the aircraft will fly in a direction in which the nose is pointing. The aircraft can fly, still I want to fly towards you, right? So this is how I'll do it. And this is how almost every other pilot is flying, because there is wind almost every other day happening. If at a time, if in Mumbai airspace 100 aircrafts are in air, out of 100, at least 50 will be doing this sort of flying. Okay. Following? So it is not compulsory that the aircraft will fly a direction in which it is heading. And it's a regular thing. Don't worry about it. And you have to be a master of calculating these easily. How do you calculate it? With the help of the understanding of wind velocity triangle, your topic for today, after directions. It's all mathematically solvable. So please write this down. Effect of air and wind on flying an aircraft. Write down point number 1. Aircraft becomes very, very free in air. Added to this, in inverted commas, free mobility, the air keeps moving in the form of wind, thus giving us a wind vector with 2 dimensions. 1, wind direction, and 2, wind speed or velocity. Whatever you call, either call it speed or wind velocity. Mostly we call it velocity. It is known as like this, wind vector. Example, 30 at 15 knots. It means wind is coming from 300 degrees at 15 knots. That is nautical miles per hour. So welcome to a new unit of distance measuring, nautical miles. Everything that we'll measure mostly will be covered by a nautical mile. All our distances along the route. How much is 1 nautical mile, students? 1 nautical miles is equal to 1.85 kilometers. You can write it somewhere in the corner of your notes. 1 nautical miles is equal to 1.85 kilometers. So it's almost equivalent to 2 kilometers. But you will not use 2 kilometers in your conversions. You will simply use your navigation computers for your conversion. Okay. I'll teach you how to use navigation computers. We have a software version for it, which we'll be using. Okay. So this effect of wind coming from 300 degrees. So you need to know what is 300 degrees. It's a direction. These are constant directions. They don't change much. The orientation remains the same. And at what speed? 15 knots. So this wind will affect you. This wind vector will affect you, and you have to adjust your heading so that you stay on your required track to fulfill your point A to point B. First point of being a good navigator. Is everybody following? What am I talking about right now? Anybody who's not following, please let me know. Anybody who's confused, any questions? I'm going to take a pause for a minute. Anyone, think about it. Go through your notes so far. See, nobody is going to ask these things in your exams, okay? What I'm teaching you right now. But understanding it in this way will really make you a very good navigation student. Okay? Because everything that you're going to study, you will know what is important for you to study. 1 minute, anybody? Manoj, Achal, Jyotsna, Neha, Rishi, Hardik, Muhammad Azam, Harsim, Utkarsh, Sardeep. Any questions so far? Go through your notes, read it, see if you understand what I'm trying to say. Height, speed, direction, relate the instruments with it, progress, position, relate the instruments with it, get it into your system. Try to learn now itself. Don't give yourself the opportunity to think like, okay, abhi likh lete hai, baad mein padhenge. Like, let's write now, we'll study later. Try to study right now. These are basics, fundamentals. Thus, aircraft has to be allowed to adjust for this wind vector, and this is done by adjusting the HEADING heading. We will write heading as HDG of the aircraft. Now I'm giving you an important note. Whatever I give you as notes are like rules of thumb or important definition. So write down note. Aircraft heading is the direction in which the nose of the aircraft points. In bracket, nose or longitudinal axis of the aircraft. Both are the same. So what is the longitudinal axis of the aircraft? Before an aircraft is made, on the blueprint, 3 axes are made. I keep reiterating this in almost every other class where it is important, because this is covered in your technical, and not everybody studies technical. So we need to know. So this is top view of an aircraft, and I'm showing you a side view on the right side, like this. So if this is the nose, and if this is the tail, if this is the wingtip, starboard side, and if this is the wingtip, port side, like this. And if this is the CG, center of gravity, this is the symbol for CG. In your navigation, you'll be learning mass and balance also. We'll talk about CG, effect of CG and everything. So the imaginary line joining from the nose to the tail of the aircraft. So you see this black line? This black line becomes your longitudinal axis. Very important. So it is aligned with the nose of the aircraft. That's why heading is described as the direction in which the nose or the longitudinal axis of the aircraft points. Okay. From the side view, this aircraft will look like this. So this will be my longitudinal axis, nose and tail. Wingtip to wingtip, just for your extra information. Wingtip to wingtip, the line that you have, or the axis from wingtip to wingtip, is known as lateral axis. It will help you when you're learning gyro instruments to get this knowledge about all axes. So from the side view, you have your wing that looks like this, but from the side view, you cannot see the lateral axis in the diagram. Okay, wingtip to wingtip. But what you see in the side view is what you cannot see in the top view. I'll show you it in red, a point like this, and this axis here is known as vertical axis. All these three axes will pass through each other and through the center of gravity of the aircraft. Vertical axis. From the side, you can see vertical axis. From the top, you cannot see vertical axis. This is vertical axis. And here I'll make wingtip to wingtip, some dot here. This is your lateral axis that you cannot see. Total, you have three axes, and the aircraft is only allowed to move along these three axes: longitudinal, lateral, and vertical. Okay. So what is heading of the aircraft? The direction in which the nose or the longitudinal axis of the aircraft points. The direction at which it is pointing. So let's say if Sauradip is at a direction of 350, Utkarsh is at 360 with reference to me, and let's say Hardik is at 010. I'll show you what directions are. Just remember 350, 360, 010. So with respect to my reference, if it is pointing at Hardik, then the heading of the aircraft is 010. Why? Because Hardik was at a direction 010. Simple. Once you learn about directions, you'll know what your heading is. If it is pointing at Utkarsh, my heading would be 360. If it is pointing at Saurabdeep, it will be 350. That is the heading. Okay. One last point about this effect of wind. Write down. Thus, aircraft doesn't always travel the way in which it is heading. You must have seen at least one point in time, some of you all must have seen how some pilots land the aircraft during heavy winds. You must have seen if this is the runway center line, you must have seen they are landing like this. Has anybody seen landings like this? Crosswind landings like this? That is a classic example of aircraft not flying in a direction in which it is heading. Okay. Also note, visibility in air is restricted to a few miles. Therefore, the pilot has to put careful attention to keep a reliable, okay, not just any guess, but a reliable check on the position of aircraft. Now take a few minutes to go through these points. What is navigation? This is navigation. You have to keep a reliable check in the end on the position of the aircraft, on the direction of the aircraft, the heading of the aircraft, the speed of the aircraft, the height of the aircraft, the attitude of the aircraft. Imagine you have 2 eyes, 2 hands, 2 legs, but the things to take care about at any particular moment would be 10 to 12 things at any given point in time when you are in a simple aircraft. And when you are in a commercial jetliner, a very sophisticated aircraft, maybe 15 to 20 things at any point in time. You will be aware, one thing at a time. You will be scanning everything. You'll be scanning the cockpit. You'll be scanning the instruments. You'll be scanning the progress. You'll be checking with the ATC, and you'll be ensuring that everything is as per the flight plan. So flight planning is also something that you'll be learning in your navigation. So velocity triangle, when I talk about velocity triangle, your topic that I am going to start is part of your flight planning. Part of it is also usable during in-flight. When I say in-flight, it means mid-air. So there are a lot of calculations that you have to do in a topic called as in-flight navigation. And there is flight planning. So you need to separate different topics in different categories so that you logically can understand what are you doing. So initially we'll be focusing on flight planning, okay, in your navigation classes. When we start, we have to master flight planning. In flight planning, there are a lot of numericals, easy to do numericals, okay. So we'll be learning that, we'll be mastering that. Once we are done with flight planning phase of it, in which I think about 60 to 70% of your general navigation is covered. Then we do in-flight navigation, which is very easy again. Once we are done with in-flight and pre-flight, your navigation, general navigation is over. After that, we go to jump onto what is known as instrument navigation, where we talk about air data instruments, gyroscopic instruments. And then simultaneously, we also study about radio navigation instruments like VOR, DME, ADF, and some more like GPS and radio altimeter and transponders. That's it. There you will finish your CPL training and you'll be ready to clear your exams with all the basic fundamentals that you need to have as a budding pilot. As simple as that. So you need to have this strategy in mind from day 1 onwards. General navigation, flight planning phase, in-flight navigation, instruments, radio navigation. That's how I'm going to proceed. Okay. We will rally between instrument and radio navigation. It's not like we'll not cover something before. Basic radio will be taught to you in between. Basic air data instrument related theory will be taught to you in between. Basic gyroscopic theory will be taught to you in between. So that you don't just think about general navigation all along. Any questions so far? What is navigation? Have we understood so far? What are we going to do? Okay. Do not make judgments. If you have any questions thinking, sir, this is right for me, this is not right for me, this is slow, this is fast, this is boring, However you feel, you have to discuss that with me. Instead of keeping such thoughts to yourself. Navigation for some students can induce fatigue if you are not used to learning a lot of things. If you are facing that fatigue, physical fatigue or mental fatigue, you have to let me know. Okay? Because I'm planning for a fast track batch, it means I'm going to subject you to some pressure instantly. Generally, what I do, I slowly build up the pressure. But because we have to make sure that we finish within a predefined period of time, I'll be training you to sustain pressure of learning and understanding and solving, mental pressure. Then physical pressure with related to sitting, staring at the screen, right? That also is tiring. You cannot just sit in one place for hours and listen to one person speaking. So initially it can get a little tough for you. Do not get discouraged if that happens. Okay, don't think it is not your cup of tea. Don't give up. If anything of that sort happens, you will discuss with me. Sir, आपने पढ़ाया but sir bouncer गया sir, क्या करूं? Simple. So you have taught me but I could not understand anything. That's how you have to talk to me. It's my job to make sure you understand. Okay. If you're not understanding, if you're thinking, oh, I'll read notes and see, I have doubts, I'll check with myself. No, don't do all that struggle by yourself. You have me, right? Wherever you are stuck, no matter what point, again and again, again and again, again and again, you have to discuss that with me. Even if you think it's your fault why you could not learn. If you think as a nice student that, okay, sir to padha diye, meri galti thi, it was my fault, sir taught me, I'll watch the recording and learn. Don't bother yourself. Tell me what the problem is, I'll tell you what to do. Okay? Expectations, students, I'm setting expectations. After the class, everybody has to share a message with me if you have any expectations. Sir, my expectations are these. Like Harsim has already told me, sir, I want you to teach me by this definite amount of time. Like Utkarsh has already told me, sir, I want to do these topics more importantly by this much amount of time. Right? So similarly, everybody can tell me their expectations. What I'm trying to say is don't think that it's just a one-way traffic thing. It's two-way. You have to talk. You have to discuss. You have to understand. And this knowledge that you're learning, you have to make sure this knowledge is very strong in your head. Now write down this couple of points. And after that, we'll take a short break. And then we will start with what we are supposed to do today. Okay. So how to become a good navigator? Now, before I give this point to you, initially, around 20 years ago, not far away, just 20 years ago, every aircraft had two pilots to fly the aircraft. They had a flight engineer to keep a check on the aircraft performance. And then they had a navigator, special navigator, who used to help with navigation because the aircraft was complicated. Now they have reduced the number of people in the cockpit. They have removed, first they removed the flight navigator. Then there were 3 people in aircrafts, 2 pilots, 1 flight engineer. Then they removed the flight engineer also. So who got the duty of navigator and flight engineer? The aircraft pilot itself. Okay, that's how it has been modified. Now, I've been seeing since more than 5 years that people are trying to say that just give one pilot aircraft, just give one pilot aircraft. Why? Because airlines want to do cost cutting to increase their profits. But an aircraft and the aircrafts that we have, they are not designed to be flown by one pilot. It's unsafe. Only 2 pilots can guarantee successful flight sector, whatever your mission is with respect to the aircraft. Okay. Only a few planes are designed to fly by single pilot. And of course, during emergencies, you will have to fly on your own, but you will realize you need an added help and you will ask your cabin crew to come and help you like you see in movies, something or the other. Okay. So what I'm trying to show you is how it is evolving. It all depends upon your hardware. If the aircrafts would have not been modified the way we have, like Boeing 737, 727, 767, these aircrafts, Airbus 320, 319, then we would have still had navigators and flight engineers. But the way they have constructed the aircraft is that they have given the duties to the pilot itself. So whatever you do, you are just basically fulfilling those duties, in-flight duties. So how do you become a good navigator? Why am I using the word navigator? Because we are learning and you have to be good with navigation. I have many students who have gone for their flying, initially for the first year of their flying or first 100 and 150 hours, I don't hear from them because they're enjoying the process. I initially hear from them when they are doing the first, second hour of flying. They say, sir, today was my first flight and this and that. And then they get in touch when, do you know? When they start instrument flying. Because they don't understand, because they've forgotten the theory. And they're like, sir, how to make sure my instrument navigation is good during flight? I'm not able to make perfect turns. I'm not able to fly perfectly as per the sector and the route given to me. Why? Why is it happening? It's all in the theory. It's all in the theory. Problem is, in flight schools, the theory is not taught to you. Only practical is taught to you. Some people understand, some people don't understand. So how to become a good navigator? Point number one, pilot has to do three things. Okay. You also have to fly the aircraft. Plus, you also have to check the performance. Performance with respect to the engine, performance with respect to the attitude, bank angle, altitude, airspeed, everything. And a pilot has to also know position. These three things. Pilot can do so by asking the following questions. How can you do it? Keep asking these questions. Number one, where am I? Always, students, remember this is gold. What I'm teaching you right now is gold for you to become a very good pilot. And this is going to separate you from other students in your batch so that you come out as the best trainee pilot in your flight schools. I'm not worried about your ground school performance. I'm worried about, not even worried. I can guarantee that if you're good here, you will be good there also. First question, where am I? Are you able to pinpoint where you are with respect to your position in air and the ground? If good, if yes, then you are a good navigator. If no, then you're lost. Simple as that, you're lost. And the problem with getting lost is that you might run out of fuel. And if you run out of fuel, you cannot just stay in air waiting for some fuel tanker or fuel flight to come and refuel you like you can do on ground. You will simply fall. The aircraft will stall and fall and crash. Second question. After where am I? Let's say you are able to determine where you are. Ask the second question in sequence. Why am I here? There are only two answers to these questions. Why am I here? One answer could be because you're supposed to be here as per the flight plan. Great. If you're not there where you're supposed to be as per your flight plan, then you'll know why am I here? Because I'm lost. Are you following, everyone? Students, I know it's been 1 hour. It could be physically stressful. Try to keep up your focus, okay? Am I supposed to be here? Point number 4. What should I do next? If you are not supposed to be here, then what should you do next is very important. It will require a lot of calculations, a lot of conversations with ATC and everything. If you're supposed to be where you are, then what you're supposed to do, you're supposed to do what you are doing, that is proceed as per your flight plan or resume your normal navigation, as we call it. So if you keep asking again and again, where am I, why am I, where I should be, what should I do next, you will realize whether you are on track or not. Which track? Required track. Okay, everyone? After these questions and necessary corrections, a pilot can accomplish the objectives of a good navigator. Students, these are skills that you will learn, okay? Navigation requires practice for perfection. Remember that, okay? You have to be vigilant. Students, this vigilance with practice and with training is induced into you. Okay? Everybody is taught a level of, a common level of vigilance. Only then you will be allowed to fly for an airline. Ultimately. And this vigilance you have to start from now, from ground studies. Why? Because the questions given to you in the examinations will be easy for you to solve if you are vigilant enough to realize what the question is asking you to do with respect to the situation. And the situation would be mostly given to you with respect to your aircraft being in air. So what you will be doing in real life in future when you start flying is what they will be giving you in questions in the examination. So you solving navigation problems is as good as you solving real life in-flight navigation problems. Are you following what I'm trying to say? Almost 60% of your numericals are like that. Utkarsh, Neha, Jyotsna, Achal, Manoj, are we following? Let me know via your chat box or via emojis. Students with their faces, I can understand. You're following or not following. Yeah. Manoj, you also assign yourself a code, registration marking. First two letters will be VT, Victor Tango, and any three letters of your choice. And rename yourself on Zoom, okay? Whenever you can do that.
Okay.
Yes. Last point. Sound knowledge of theory of navigation is sufficient. If you are thinking why and what about this whole navigation and the tension behind navigation and the DGCA exams, sound knowledge of theory of navigation is sufficient to cover the requirements of any particular flight, any and every particular flight. So this is why we study theory of navigation. We also have an overview. We have also established a base of what's coming in for us. But these basic points will determine your character as a pilot. And all pilots have a similar character. That's why aviation is so safe, because it's induced in your training. And ICAO controls it, International Civil Aviation Organization. They control it. So thus DGCA controls it. Okay. Any questions, students? Apart from sir, when is the lecture ending? Any question? Anyone sir? आज के लिए बहुत हो गया, बोर हो रहे हैं. Utkarsh, how are you feeling? Manoj, how are you feeling? So, Saurdeep, how are you feeling? First time for you all after a long time.
Good, sir. No problem.
No problem, Saurdeep. Utkarsh, how about you? होगा नहीं होगा उत्कर्ष?
सर होगा सर होगा.
कर पाओगे नहीं कर पाओगे?
नहीं सर अरे.
Manoj, what about you? How are you feeling? Is it too much?
Theory is too much, sir, than numericals.
It is too much, but can you do it?
Yeah, yes.
Definitely good. Very nice.
Sir, it's
Arjun?
like CP point, critical point of aircraft.
Yes. These points, this is one time thing. And if you realize, then you can actually revise navigation in 2 hours. The entire CPL syllabus you can revise in 2 hours.
Okay.
If you go ahead with this approach, students, trust me on this. It is that easy. That's how you guarantee your first attempt clearance, right? How else will you do it?
I am
Okay,
good
fine.
in general now, sir, but radio nav I want.
Yeah, we will come there, but we'll also cover general nav, Manoj. Okay?
Thank you.
Yeah, you cover everything to pinpoint if you have any mistakes. For you also, Utkarsh, if you're thinking, sir, mujhe itna hi karna hai, itna nahi karna hai, I would suggest, don't think like that. Just do everything. If you want any topics on priority, you can always request. Okay, fine. Any questions? Aanchal, Jyotsna, Rishi, Neha, Hardik, Harsim, Mohammad Azam. Take a look at all that you have seen. Remember these points. Even radio navigation is all about these points. Okay, knowing your position, knowing your progress. That is what it, RMI, RBI, reading the instruments. What I'll do is I'll start radio navigation after we have done around 50% of general navigation, okay? At least a few basic topics so that students who are worried about radio nav, you get exposure beforehand only. Okay, I'll make sure I do that. So don't worry about it. I'm not going to stretch just general nav for a long time, and then I'm going to give you everything initially, everything, basics, so that you know what's in store for you. 1 more minute I'm giving you before we go for a break. Go through what I have given you. Go through your notes. See if you have any questions. And please take it easy in class, okay? Like relax, enjoy, remember to smile. If you have any jokes, you can share aviation related jokes. If you want, I can crack jokes, but then you will not laugh at the joke. You'll laugh at me. Mohammad Azam knows it. Utkarsh knows it. I'm very bad at cracking jokes. This weekend, I cracked a joke in front of a friend, and the friend got offended. I'm like, why are you getting judged? It was just a joke. You know, right? Like I give this disclaimer to everyone, you know, like I started with 50% success. I've reached 52% now. Utkarsh, last time 50, then 51, now 52. Okay, fine. So I'll see you after 15 minutes. I'm giving you a good amount of break, 15 minutes. We'll come back at 1, 2, 2, 5. Correction, 1, 2, 3, 5. We'll start with directions. Let's see how much we cover organically. It's not compulsory. We have to finish everything. Maybe velocity triangle, if we are not able to cover, we'll cover starting in the next phase. So we have to be very organic and flexible and enjoy, okay? Relax. First thing, relax. Everybody is so serious. I'm like, what am I doing with you? I don't want you all to be this serious. I want you all to learn and understand. Be serious also, but be very nice also. Like, yeah, I'm here because I want to do it. Okay. So short break till 1, 2, 3, 6. 1236. Yes, 1236. Hello, everyone. Welcome back. Let me know, students, if you are back. Students with videos off, let me know if you are back. Okay, so Sardeep, share your
Yes, sir.
experience so far. How you feeling?
So everything has been going fine, no problem. Like it's fine, sir. No problem. Perfect.
Okay, everything is fine.
Yes, sir. Are we going to do the wind vectors today? That is like the velocity triangle.
I want to do it. Let's see how much can y'all sustain. How much can the class sustain? I am ready to teach you everything. Let's see how much can you sustain. I won't overload your minds. I would never do that, especially when you're learning basics. Okay. Actually, the entire CPL syllabus is considered to be basics, but we will be dividing it into a basic level, then a mid level, and then a final level for us. Utkarsh, share your views. How are you feeling so far? Utkarsh
I'm
is-
feeling interested, like RS a throw interest.
thoda, thoda. Utkarsh,
Navigation is like for me very boring.
for you, very boring, right? Utkarsh, Utkarsh must be thinking, सच बोलूंगे झूठ बोलूं कैसे बोलूं? Finally, you are telling me the truth. I like that. If it gets boring, you have to make it interesting by conscious thinking, students. Psychology. Okay. Initially, these are initial drags, we can call it. Okay. So Utkarsh, आपके लिए बड़ा challenge है. It's a big challenge for you. Let's see. Good. Utkarsh, don't worry about thinking that ये मैंने पहले किया था नहीं किया था. Consider everything to be as a fresh topic. Okay, because I know you have attended many sessions in the past when you were just beginning. So don't worry. And one more, Neha and Rishi are back, right? Hardik, Mohammad Azam, you're back, right? Anchal, Jyotsna, Manoj, you're back. Manoj Kumar, Jyotsna, Anchal, Jyotsna, Roger, Anchal, Roger, Rishi, Neha, I think you're there, right? Hardik, nice to see you again. Mohammad Azam and Manoj. I think Manoj is yet to come back. Manoj, are you there? You're on mute. Okay, fine. Mohammad Azam is here. So I think Manoj, I cannot hear you, Manoj, if you're there. Directions. The first thing that we learn in navigation is directions. If you can master directions, your general navigation is taken care of and your radio navigation is taken care of. What did I just say? I said, if you master directions, your general navigation and radio navigation both is taken care of. So directions is at core, okay, at the epicenter. By the way, Saurdeep, were you asking because you have somewhere to go?
No, sir. No. Just wanted to know what we are doing today.
Yeah, we will do both. If not in detail, I'll at least introduce the wind velocity triangle to you all, definitely. But let's come one step before that. Let's talk about directions. Now, you must have heard growing up in your standard 10th, in your standard 8th, or maybe standard 12th, that life mein direction hona zaruri hai. You need direction in life. You need to have a goal, what to do. Your goal is to become a pilot, or maybe you had many goals. One of them is to become a pilot, right? Similarly, a pilot, a real life pilot, also has a direction in which he or she has to fly. And the direction is not just one direction, it could be a set of directions that you have to follow. If you follow those set of directions, you're guaranteed to reach your departure point. Let's assume a situation. Okay. Let's assume a situation where I have to fly from point A to point B, these triangles. The problem is I have a lot of mountains between point A and point B. So how will I fly? During my flight planning, I will determine this route like this. Now this looks like a very safe route to fly. Okay. Now how do I measure this route? How do I make sure that I can measure the route and I can follow the route? So I need certain numbers associated with it. So this route, firstly, will be connected by a lot of ground stations. These triangles will represent a ground station. Okay, like this. And it will be helpful if I could give the direction maintained by this route from waypoint 1 to waypoint 2, then from waypoint 2 to waypoint 3, and then from waypoint 3 to waypoint 4. So I can break down my entire flight not into one direction, but phases of flight, like from waypoint 1 to waypoint 2, waypoint 2 to waypoint 3, waypoint 3 to waypoint 4. Now, it becomes much more easier if I know the directions. This route might be called Alpha 474. This route might be called Whiskey 10. This route might be called Whiskey 10 East, like this. Okay. So now you know that you're supposed to be on these routes. You're supposed to take Alpha 474 from waypoint 1 till waypoint 2. At waypoint 2, you have to turn right for Whiskey 10. Then at waypoint 3, you have to again turn right for Whiskey 10 East. And then you will reach waypoint 4. That is your destination. Now you have much more information to fly safely. But how do I maintain this route? You will have radio navigation instruments to help you maintain the route. But there's another way you can maintain the route, by knowing the direction of the route and maintaining that direction. Okay, so direction is very important. Now, if I know the direction 0, 1, 0 degrees, and if I have a directional navigation aid in the cockpit, then I can just align that instrument with the number and I can maintain this direction. So from waypoint 1 to waypoint 2, my direction could be 0, 1, 0. From waypoint 2 to waypoint 3, my direction could be 0, 8, 0. And from waypoint 3 to waypoint 4, my direction would be 1, 0, 0 degrees. Now we need to understand what are these values and how these values originate. Okay. So now I know the direction to fly is 0, 1, 0, 0, 8, 0, and 1, 0, 0. It means the directions are increasing from 0, 1, 0 to 0, 8, 0, and then 1, 0, 0. And it also tells me that I'm flying in this direction. Which is this direction? This is a right direction. This is called as east. You're flying in east. How do I know this is east? You will learn everything now. Okay. You will learn why I have given it 0, 1, 0 and not other value. You will learn why I have given it 0, 8, 0 and not any other value. You will learn why I have given it 1, 0, 0 and not any other value. So directions are very important. Now, in order to get directions, we need to know a little bit about this thing that we see, the Earth. The Earth on which you will be flying. Okay, you need to know about this Earth also. But I'm not going to start your navigation studies with the Earth. I'm only going to use one reference of the Earth, that is the North Pole of the Earth. Earth rotates about its axis, okay? And that axis passes from the North Pole to the South Pole. This is known as the magnetic North Pole and magnetic South Pole, the actual axis of rotation. Okay, magnetic North and magnetic South. So we need to understand about directions. The first thing is that Earth has a magnetic North Pole, MNP, and a magnetic south pole. And the Earth rotates in this direction about this axis. Axis of rotation, also known as polar axis. And the direction in which Earth rotates in space about this axis is known as east. Point number 1, Earth rotates about its polar axis in direction east. First things first. Now, this is a natural reference that we have. Okay. A natural movement of the Earth east in that direction. How does it look like in real life? With my perspective, this is east. You are looking from the opposite side. For you, it's the opposite direction because you're looking at the globe from a perspective that is totally opposite to me, like that. If I change the perspective, then you can see east and I can see west, like that. But we'll come to that. Remember, Earth rotates about its axis in east. Earth has a extreme Earth has two extreme points at the end of the axis. That is magnetic north pole and magnetic south pole. These are two extreme ends of the axis of Earth's rotation. Magnetic north pole and magnetic south pole. Okay. Earth has two extreme points at the end of the axis, or we call it extremities also. One is magnetic north pole and magnetic south pole. Magnetic north pole is taken as a reference to measure directions. These directions are called magnetic directions because they are measured with reference north. With reference as magnetic north pole. Not just north, but with reference as magnetic north pole. Point number 4, write down. If I'm too fast, just let me know, sir. Wait. Like that. Utkarsh, are you following?
Yes, sir.
Good. Hardik, are you following?
Affirm, sir.
Rishi?
Affirm, sir.
Neha?
Affirm, sir.
Good. Manoj, are you back? I'm not sure what's with Manoj. Manoj, you're on mute. Okay, if you're back, I cannot hear you. Magnetic north pole. Okay. Magnetic north pole Important point to know. MNP is not a fixed point. Magnetic North Pole changes its position due multiple natural causes. Thus, using magnetic North Pole as reference for directions is not dependable all the time. Now, students, these points we are giving in writing because you cannot avoid to miss this point. The problem with the Earth's magnetic North Pole is that it doesn't stay fixed in one point. Okay? Because of the property of the Earth is such that this magnetic North Pole keeps changing its position at a particular radius. Now the changes happen annually, 10-yearly, and then the changes can happen anytime. Okay. So what I'm trying to say is that when you look at the Earth from top view, this should be your North Pole, magnetic North Pole, ideally in the center. But the North Pole doesn't stay in the center, but it keeps changing its position like this. It will cover this circle. Sometimes it will be here. 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 It keeps changing its position. Magnetic north. Okay, so it is not reliable to measure. But why do we use magnetic north as a reference to measure directions? Because different positions of magnetic north pole over a period of time. Remember, this diagram shows that. So what do? We use a fixed reference known as geographical North Pole is used known as true North Pole. That is true North Pole. So this in the center that I have made is actually your true North Pole. It is fixed. It doesn't move. It is also known as geographic North Pole. Now this geographic North Pole is fixed. It means there is a flag planted in the northern hemisphere, somewhere in between where the magnetic North Pole rotates, a fixed position known as geographic North Pole. Now, if I measure my directions with respect to this geographic North Pole, I'm always going to get the correct directions because it doesn't move. But if I use magnetic North Pole as a reference, then there is no sorry, there is no guarantee because my magnetic north pole keeps changing its position. Okay. The reason we use MNP, that is magnetic north pole, is because it is the only natural directional reference that can be sensed by what is known as a magnetic compass. A magnetic compass is self-dependent and can show magnetic directions at any given point in time. This magnetic compass in the aircraft also, students, it operates on its own. It doesn't require aircraft power. It doesn't require electricity. It doesn't require anything. So in the event of power failure, in the event of engine failure also, if everything else fails, you will still have your magnetic compass under the influence of the Earth's magnetic field. So what is this magnetic compass? How does it sense the magnetic directions? All this will cover when we do magnetism. But we need to know what these directions come up from. In olden days, when people used to travel the earth using ships, naval ships, they had only a compass for navigation, nothing else. So when aviation sprung in the beginning of the 19th century, 1901 onwards, magnetic compass was used for navigation. Then they started making charts to show the earth to the pilot when the pilot is in air. But these charts, on these charts, we were mentioning magnetic directions used to magnetic north. But later on, they realized that magnetic north is changing its position. So they had to update the charts also regularly. Now, the problem was such that the magnetic north, it cannot be predicted as to when it changes. It can only be studied. Okay. It can only be studied. It cannot be predicted. So chances are the magnetic north might change its position when 1,000 pilots are still in air flying using the same charts. Then what to do? There will be an error because magnetic north has shifted, the reference has shifted, so that there will be an error in the direction. So all those pilots will get lost. So on the navigation charts, magnetic north is not a good reference. We need a fixed reference. That is true north, the geographical north. To avoid errors related to magnetic north pole shift, we use true north as a reference on all navigation charts. Therefore, there will be two directions. One, magnetic direction. In bracket, you will write measured from magnetic north. And the second is true directions, which is measured from true north. Important note. Now talk about the difference. Any difference between the two norths. Let's say the true north is in a different position and magnetic north is a different position. So there is a difference. Any difference between the true norths is known as, inverted commas, variation. The value of variation is given in degrees east or west of true north or true direction. Note, when magnetic direction is east, in bracket write RIGHT, right, of true north, it is known as easterly variation. And next note, when magnetic direction is west, that is left of true north, it is known as westerly variation. Now, students, this variation is a very important topic for you. Lifetime, you are going to see this word variation on your navigation charts. Why? Because on the navigation charts, true directions will be mentioned. Okay. I'll show you the difference and everything when I show you how to measure these directions. And then along the route where the true direction is mentioned, like let's assume this route, this red route that I have made from Alpha 474 Whiskey 10 Whiskey 103. So this 010, 080 and 100 are actually true directions if this would have been a route on the chart. What if everything fails and you have to use magnetic compass? Then you have to follow magnetic directions. How do you find out the value of the magnetic direction? Or how do you relate your true direction on your magnetic compass? You do it with the help of a simple relationship between the true direction and magnetic direction. Okay, it will be like this. Variation 7 degrees east, like this will be written on your navigation charts. It means your magnetic directions are 7 degrees right of the true directions. So if your true direction is 010, 7 degrees to the right, is it plus or is it minus? If it is plus, you will do 007. What will you get? 017 degrees will be your magnetic direction, like this. And if the relationship is minus, then you will get 003 degrees magnetic. So with the help of this value of variation and you learning the relationship that I'm going to teach you, you see what direction you have to follow on the compass. So on the compass, you will be maintaining 003, and on the chart, you will be maintaining 010 by default. This is how you will be navigating if you are using a compass as a reference. So on the charts, there will always be true direction. but you will be required to find out the value of magnetic direction so that you can use the compass to fly with the compass. Why? Harsim, stand by with your doubt. Make sure you don't forget it. 5 important yet basic instruments needed by every pilot for a safe flight. Number 1, eyes. Number 2, brain. Number 3, charts. Number 4, stopwatch. And number 5, a magnetic compass. Remember this, everyone. Eyes to observe, brain to calculate, charts to navigate as per Earth, stopwatch to calculate speed, distance, time, and compass to find or follow directions. So charts will always have true directions, while compass will show you magnetic direction. So you have to know the relationship between true direction and magnetic direction. And the difference is variation. And today that is what we are going to learn. But we need to know the Earth rotates in a direction known as east. And this east also has a value. Victor Tango Hotel Alpha Romeo, go ahead. Harsim, you had a question, please go ahead.
Sir, how will we know, like, how much is the variation? It is in plus or minus?
Variation is mentioned on the chart. Okay. And there is a thumb rule. Let's do it now. How to find whether variation value should be added or subtracted. Answer. Follow the poem. Variation east, magnetic least. It means whenever it is shown to you on the chart that the variation is east, let's say by 7 degrees, then the magnetic value will be least. Least to what? Compared to the true direction. So you will subtract that from the true direction. So whenever your variation is east, it is subtracted from your true direction. Variation west, magnetic best. It means if on the chart variation value is shown to you as a westerly variation, then that value will be added to a true direction. Example, if true direction is 010, example 1, okay? Variation is 10 degrees east. Find magnetic direction. Solution. Variation east, magnetic least. It means 10 degrees east has to be subtracted from my true direction so that the magnetic value is lesser than true direction. That's how you can always easily remember. Either add or subtract. The second strategy is easterly variation, you always subtract minus value. But first remember, variation is magnetic least, because you'll be learning so many concepts that chances are you will get confused. So these rhyming words, every student pilot is taught so that you don't forget. So solution, as variation is east, magnetic will be least. Therefore, 10-degree east variation is subtracted from 0, 1, 0. Therefore, 0, 1, 0 minus
0, 1, 0.
0, 1, 0 is equal to 0, 0, 0 degrees. 0, 0, 0 degrees is equal to 360 degrees. They both have the same value. Okay. So on a magnetic compass, therefore, on magnetic compass, follow 0, 0, 0 magnetic to stay on 0, 1, 0 degrees true as per the ATS chart. Do you understand, student? We are following a different number and we are tracking a different number. So on the magnetic compass, I'll follow 0, 0, 0. That is magnetic north only. And as per the true chart or the ATS chart, I'll be tracking 0, 1, 0. So with this example, here, if I change the variation value to 10 degrees, 0, 1, 0 east, 10 degrees east, then it will mean that as per my magnetic compass, I'm following this direction, which is 0, 0, 0. And the difference is 10 degrees east like this. But this in reality is not the right diagram to show it, because the variation is 10 degrees east. So now we know the application to add or to subtract and to find the correct direction. But we still need to know how is this direction measured from a reference that is north. And that is of utmost importance if you have to build strong fundamentals for your navigation. Okay. Any questions? Harsim, please. Yeah, so that was your question. Okay. Any questions, students? Think about it. Utkarsh, Neha, Rishi, Jyotsna, Aanchal. Are you following? Is there a confusion? Is there a problem? Utkarsh, these are scoring points.
Negative, sir.
Hardik, Harsim, Mohammad Azam, Saurdeep. Let's take one more example and you give me your answers in the chat box, everyone. Okay. The answer to the second one. Aanchal and Jyotsna, let me know if there is a confusion, if you're following. I'll repeat again if you want me to. Rishi, also let me know. Example 2. If RT, required track, is 150 true. Okay, it means you have to follow this track. Variation is 5 degrees west. Find magnetic track or direction to follow. Please use the law and give me the answer. Everyone answer in the chat box. And along with the direction, if it's a magnetic direction, you will write M. after the numbers. I'll cover up the numbers after this. I'll show you how directions are measured. So we know variation west, magnetic value will be best. Best means higher than the true value. Muhammad Azam, variation west, magnetic best. Always relate with that. So magnetic has to be better than the true value, higher. Will you subtract or will you add? You will add. Everyone. So what is the value of true direction? Option A, 155 degrees. Option B, 145 degrees. And option C, 165 degrees.
155.
So you will say option A, B, or C. Let me check. Jyotsna, correct. Utkarsh, correct. Very good. So Sardip, correct. Well done. Muhammad Azam, make the correction in your answer. Achal, correct. Rishi, correct. Hardik, correct. Well done. Harsim, correct. Hardik, have you given the answer? It was Harsim's answer.
Yes, sir. A.
A, right? Correct. Good. Everybody? Good. You can assure yourself 1 or 2 marks in the examination already. Okay. You have to score above 70 to clear. This much understanding definitely will get you 2 marks. So if you're worried about scoring 68, then you need not worry because 2 marks are in your bag. You'll get 70. Like that, you can think about it. The importance of 2 marks. Even if you don't study and go properly, students end up scoring 40, 50, 55 by default. I don't know how they do it. That always happens. Even without study, students can score that much. I'm like, how can you do that? That's some talent. The problem is getting those extra 20 marks. Okay. So we are fighting for 80, 85. We want that kind of a score. 85, 87, 90 in your first attempt. Why not? So this is the correct answer. Any doubts, anyone? A compass shows magnetic directions, but under the influence of aircraft's own magnetism. Thus, the information received by magnetic compass is not an accurate reading of the magnetic direction to fly. Read these 2 points again. A compass shows us magnetic directions, but under the influence of aircraft's own magnetism. Thus, the information received by magnetic compass is not an accurate reading of the magnetic direction to fly. This difference between compass reading and actual magnetic reading is known as deviation. Harsim, go ahead.
Sir, as you just said, the compass is not is not the accurate reading.
It is not an accurate reading because it is under the influence of aircraft's own magnetism. Students, because aircraft has a lot of electronic circuits, a lot of metals involved, it also acts as a magnet in itself. Okay, we'll learn more about aircraft magnetism, Earth magnetism when we do magnetism. But a compass senses Earth's magnetic field to show us direction. Okay, it points towards magnetic north. But more sensitive, rather than being more sensitive to the Earth's magnetic field, because the aircraft is in the immediate vicinity, and that is the cockpit, of course, the compass is also in the cockpit. It is influenced by the aircraft magnetism also. So the ability of the compass to point in a magnetic direction is reduced because it is under the influence of the immediate aircraft magnetism. And this difference, known as deviation, is actually pre-calculated by the manufacturer itself. Okay? And the corrections that you need to apply to your reading are given alongside the compass in the cockpit, known as compass correction card. In what is known as compass correction card. So that value will be given predetermined in the cockpit. Depending upon where you are, the small table against the magnetic compass, a small card, it's a metal card or a paper card you can replace. It will show you if you're on this heading, then this is the deviation. If you're on this heading, this is the deviation. If you're on this heading, this is the deviation. You have to account for the deviation to get actual magnetic, like you accounted for variation to get your actual true direction. So Harsim, please ask your question. Magnetic reading is not correct. How can we correctly fly in training aircrafts? We allow for the deviation. Okay, you will be taught. Those basic things will be taught to you. And in training aircrafts also, it's not just the compass that you will have at least a gyro compass. A gyro compass gives you accurate readings. So in your basic aircraft, gyro compass will be there. But today we are not talking about gyro compass. In training flights, you will have gyro compass. In reality, your training flights, smaller aircrafts, bigger aircrafts, they all will have a magnetic compass as a standby instrument, not a primary instrument, just in case of failure. So you are taught it as a first thing, as a base. Are you following? The first thing taught to you is the worst case scenario thing taught to you. Imagine the level of fail-safe in aviation. We call it fail-safe training. Aviation follows a design pattern known as fail-safe. Fail-safe. It means if one thing fails, there is another thing to protect the system from collapsing. If the second thing fails, there is a third thing in the design to protect from the system from a total collapse. So that's why everything has a standby. All instruments have a backup instrument in aviation, in the aircraft. So your magnetic compass, you will not actually use your magnetic compass while you're flying. But what if everything fails? Then you have to only rely upon the 5 basic instruments. What are they? The charts, which are physical charts, your eyes, your brain, a stopwatch, and your magnetic compass. Okay, following students. Good question, Harsim. Do we understand what is deviation? Any confusions, anyone? Utkarsh, Achal, Jyotsna, Rishi, Neha?
Negative, sir.
Jyotsna and Neha? Okay, fine. Let's write down the relationship. Note value of deviation in bracket, right? Whether east or west, I'll give you the definition, is pre-mentioned in the cockpit on a compass correction card situated close to the magnetic compass. Remember, we are not learning about what is a compass, what is Earth's magnetic field. All that we'll do when we are doing magnetism. To find actual magnetic direction from compass indicated direction, use the following poem. The poem is what I have added because it's rhyming, right? Write down. Deviation east, compass least. Deviation west, compass best. Same law. One more note. When CN, that is compass north, is east, in bracket right. When compass north is east of magnetic north, it is known as easterly deviation. And same, when compass north is west, that is left of magnetic north, it is known as westerly deviation. Let's solve an example. A compass gives you a direction of 146 degrees. See, like this. Your deviation is 11 degrees west. Find magnetic direction. Write your answers in the chat box. So, deviation west, compass best. It means compass value will be more than the magnetic value. Okay? Deviation west, compass best. Remember, compass best. When you talk about deviation, it's compass. When you talk about variation, it's magnetic. So if compass is best, it means 146 will be a higher value. It means 11 degrees I have to subtract from 146. So how much do I get? Let me check your answers. Everybody is giving me an incorrect answer. I have got 3 answers, but they are incorrect. Achal, correct answer. Good job. Students who have submitted your answers, check. Hardika Neha, correct. Focus, vigilance. Remember, we spoke about vigilance. Mohammad Azam, follow the rule, cross-check your answer. Jyotsna, correct now. Utkarsh, follow the rule, listen to the rule and then apply the correction. Deviation is west. It means compass has to be best. It means 146 has to be the higher value. So what will you do? You will subtract. Mohammad Azam, your corrected value is correct. Students not finding the correct answer, let me know. Look at this solution. As deviation west, compass best, 146 will be higher than magnetic. Therefore, 11 degree west will be subtracted from 146. 146 minus 011, 531 is my magnetic direction. Answer 135 magnetic when deviation is 11 degrees west and compass direction is 146 degrees, the compass. Rishi, correct. Utkarsh, tell me if you have understood this point. What's the correct answer? Is it 157 or 135? Whoever has given an incorrect answer, please give me a correct answer in the chat box. Yes, Harsim, always follow west, best, east, least. Always follow that to verify your answer. Whenever deviation is west, of course, you will be subtracting the value of deviation. Utkarsh, any confusion? Students who gave me 157 as the answer initially, you have to be extra careful because your auto suggestion in your mind, the technique that your mind is picking up is opposite to what I'm teaching you. So you have to train your mind to unlearn that what you're already guessing and follow my voice carefully and tell me if you have any confusions. Are you following, everyone? Nobody should face difficulty in coming to an answer in this situation. Anyone, any troubles? Utkarsh, Mohammad Azam, others, whoever gave me 157 initially. So Rishi is asking, what is the difference between variation east and deviation east? So deviation, east or west, is the difference between compass and magnetic. Okay. While variation, be it east or west, is between true and magnetic. So that is the difference. Rishi, are you following? What is deviation? Difference between compass and magnetic. What is variation? Difference between true and magnetic. These are your three directions, students. And when we learn about directions, we learn about all these three directions, and there is a way to find out either one of them. Deviation will be given to you compass cards. Variation will be given to you in ATS charts. So you don't have to worry about where will you get the values. You'll always be given variation and deviation. A required track also will be given to you on the chart. You just have to make the corrections and make sure you follow the correct reading on your compass. If you're using a gyro compass, you don't worry. If you're using a normal compass under a circumstance that everything has failed, then you just apply for these corrections and you will be able to reach your destination accurately. Students, I want to share something that you'll be learning ahead. Okay. 1 degree difference on Earth, 1 degree difference on Earth can cost you 60 nautical miles, a maximum that I'm talking about if you're on the equator. If you're following 1 degree of a wrong direction to reach your destination, you can be off your destination by up to 60 nautical miles. That is almost 120 kilometers. It's like you will be in a different city altogether. And such a deviation from your actual place position is not good because you must have wasted that much of fuel and then you have to fly back 60 nautical miles to reach your destination. You might not have that much of fuel left. So this 1 degree 60 nautical miles on the equator is the maximum distance I'm talking about, degrees converted to distance. So we cannot afford to be on a wrong direction or a wrong track. So all your general navigation is all about tracking the correct track and coming back on the correct track and so on. Knowing your present direction, knowing your required direction, and then flying accordingly. Are we following? Any questions? Any questions, anyone? Okay. So I think as we are approaching an end time, we should come to this point. CDMVT. C stands for compass, D stands for deviation, M stands for magnetic, V stands for variation, T stands for true. The representation of compass north is given by this pointer. Everybody make this, okay? The representation of magnetic north is given by this pointer, half diamond. And the representation of true north is given by this reference, full diamond or a full triangle. Representations of norths. Compass north, magnetic north, true north. Okay. Make sure you remember this. Students, any doubt you will discuss with me, okay? Upfrontly, directly, not being afraid of any judgment whatsoever. Now we will write points about variation quickly. Point number 1 about variation, write down. It is the difference between true north and magnetic north. Understand, in questions and exams, you will be required to find out the directional value, but the definition talks about the difference between true north and magnetic north. Okay. So there are two types, easterly and westerly. Okay. Easterly variation, westerly variation. What is easterly variation? When magnetic north is east of true north, east is right. So this is your true north, always fixed. And this is your magnetic north, like this. Comparison between the two. It is on the right, that is east. And westerly variation, your true north will always be straight. Remember, true north will always be straight. And this is westerly variation. So I'll write it in sentence in green. Easterly variation is when magnetic north is east of true north, and westerly variation is when magnetic north is west of true north. Easterly variation is given a plus symbol and westerly variation is given a negative symbol. Do not confuse the symbols with addition and subtraction. If they say variation is plus 10 degrees, it means it is easterly variation. And when variation is east, magnetic is least. So you will subtract. Okay, represented by plus symbol. And this is represented by negative symbol. Okay. So it's the relationship. The actual definition talks about this. It's the relationship between the norths, true north and magnetic north. And remember, which is the fixed north? True north. So the fixed north will always be a straight line in your diagrams. There are certain numericals that will require you to make such diagrams also. Is everybody following? Any confusion? One step at a time. You're just getting started, students. I'm giving you little extra than what I give students generally in the first class. Why? Because I know most of you all already have learned something or the other on your own. And because we want to study quality effectively in the least possible amount of time. So if you're troubled, share with me. Okay, I'll go slow. Let's quickly write down about deviation. What is deviation? It is the difference between, now this is the real definition. Okay, difference between the magnetic north and compass north. Magnetic north and compass north. So with respect to this, your magnetic north is in the center. So you have two types of variation. Similarly, you have two types of deviation. Easterly deviation and westerly deviation. How would it look like? Easterly and westerly. Easterly deviation, the magnetic will be, and whenever the compass is on the east, this is easterly deviation. And westerly deviation, magnetic and compass is on the west. Compass north is east of true north. Not true north, magnetic north. Magnetic north. Deviation, compass north and magnetic north. Compass north is east of magnetic north. And in westerly deviation, compass north is west of magnetic north. Now, one important thing I want to show you before I give you certain numericals is how are all directions measured? Okay. Question. Answer. Clockwise from reference north, via or via angular measurements. This is the most important rule of thumb, and I've kept it for the last 10 minutes of our session. It's because this is the most important element you should take away with you at the end of the session. This is Earth. Let's say this is fixed north, true north over here. So this is my reference. I take the center. I start measuring from this reference. I give this reference a value 0, 0, 0. All references start with 0. True. Clockwise measurement. As I make 90 degrees, angular measurement 90 degrees clockwise, the direction I get is 0 degrees. True. This is known as east. If I continue my angular measurement clockwise, when I complete this angle, 180 degree angular measurement, this direction that I get is known as 180 degrees true. And the name given to this value is south. When I continue my angular measurement from reference north up to an angle of 270 degrees, I get this direction, which is 270 degrees true, also known as west. And when I complete the angular measurement, one full circle, I get the direction from where I started, 360 true. So 000 and 360 is the same. All angles, correction, all directions are angular measurements from a reference north, measured clockwise. A very important note. All directions are angular measurements measured from reference north in a clockwise direction. These 3 points are very important, students, for entirety of your general navigation and for your radio navigation. So Utkarsh and Manoj, I don't know, Manoj got disconnected. But if your radio navigation is difficult for you, it means your understanding about directions is difficult. It's not clear. Fundamentals. Are we following everyone? All directions are angular measurements measured from reference north in a clockwise direction. East, that is 090. West, that is 270. North, that is 000 or 360. And south, that is 180, are called cardinal points or cardinal directions. Means main directions, major directions. Quickly write down next point. 045, that is north east. 135, that is south east. 225, that is southwest. And 315, that is northwest, are known as quadrantal points. One of your radio navigation instruments called as ADF is affected by quadrantal error. It means if it is on a directional heading of 045, 135, 225, or 315, it has errors. This method of angular, clockwise, directional measurement is known as sexagesimal system. Almost 50% of your numericals are based upon this hexadecimal system, students. It has a base of 60 or 6. Like we have a decimal system with a base of 10. We have a sexagesimal system with a base of 6 or 60. Your clocks, your watches, and your directions, your compass, and everything in aviation is based upon this only. Base of 60, base of 6. How many degrees do we have in a circle? A circle is divided into 360 equal parts, 1 degree each. We get 360 degrees. So in black is cardinal points, and in red, so this is northeast, this is southeast, this is southwest, and this is northwest. These are your quadrantal points. 045, true. 135, true. 225, true. 315, true. Why true? Because the reference was true north. I know everybody is tired, probably. Just a little bit of more focus I want from you. Now, if I show you that the magnetic north is somewhere here, okay, where it is now, is it on the west side? So I have westerly deviation, westerly variation. So my polar axis is like this, actual axis of rotation. So your magnetic directions will vary. Why? Because you're measuring clockwise. So your clockwise 90 degree will end here only. 090, magnetic. Then if you continue, this will be 180, magnetic. If you continue the same way, you will get 270, magnetic. And if you continue, you will get 000, magnetic, or 360, magnetic, like this. So at any given point in time, there will be two directions. For certain numericals and calculations, we'll also include deviation as and when it comes. Otherwise, these two are enough for you for real navigation. So to make sure that my elements are more easy to understand, I'll make the north like this. It indicates magnetic north, half diamond. And I'll show true north as full diamond. So now you know what is westerly deviation. Now this is westerly deviation, when your true north is actually right of your magnetic north, or your magnetic north is left of your true north. This is with respect to this person now, the person looking at the earth from this reference. A person looking at the earth from another reference, the perspective will change. We will learn this eventually on different levels when you're learning deeper levels. But do you see the difference between the true directions and magnetic directions? The system is known as hexadecimal system. What is it? Angular measurements in a clockwise direction from reference north. Angular measurements from clockwise reference north. Okay. Now I'm going to show you one numerical example. Please focus carefully, even if we have to stretch a few minutes extra. Why? Because afterwards, sometime during the evening, I'm going to email you a set of numericals to solve based upon this relationship between CD and VT. And you have to submit it before the next class. And I think your next class is on Friday. Right, everyone? So you will submit the answers via email before the next class. Take your own time to solve. All right. I'm just going to show you how it's going to be. Okay. Any questions, anyone? So let's say question number 1. Aircraft true heading is 315. Variation is 5 degrees east. Find aircraft magnetic heading. If deviation is 6 degrees west, what will be compass heading? This is the entire question. Now, students, utmost attention I need on the diagram that I'm going to make right now. Utkarsh, you there? Jyotsna, Neha, Rishi, Mohammad Azam, Achal, and
Affirm, sir.
Neha and Jyotsna. Utkarsh, are you crying, Utkarsh?
A little bit.
I know, I can understand. Don't. You will get there. Trust me, maximum 2 or 3 months, maximum for you, and you'll be free of this. Make sure it's 1 day at a time. Okay, 1 day at a time.
Sir.
What will be the compass heading? So very simple, students. How will the diagram be? I'll show you today, and I'll show it to you again and again till you get it. First, make true north, everyone. Step number 1, solution. First, make true north like this. This is where you'll get confused if you don't follow. Now, with respect to true north, what is my aircraft heading? 315. So where do I get 315, students? If I do angular measurement clockwise from reference north, where is 315? This is 315. Does everybody agree? This is 315. We just did it, right? 315. Yes. So this is where your aircraft is heading right now. So you will make an aircraft like this, a longitudinal axis, a lateral axis, which will show the wings, and a small showing you the elevators or the horizontal stabilizer like this. So this is the direction in which the aircraft is flying, true direction. Okay. This is how you will plot it. Utkarsh, are you following? Last time you had confusions here, Utkarsh.
Yes, sir.
Good. So this is the first step. True north ko apni jagah pe rakho and measure clockwise sexagesimal system and measure whatever your heading is given to you. Second point, variation is 5 degrees east. What is the definition? That the definition says that my magnetic north is 5 degrees east of true north. This, how much? 5 degrees east. So now they are asking you, so if you are able to plot your magnetic north properly, and this is how it will be, right? Easterly variation, everybody agrees? Yes, no? Yes, I'm assuming yes if nobody is saying no. Okay. Now what is your magnetic heading? So you already know where the aircraft is. You will have only one aircraft. Do not get confused thinking there will be 3 aircrafts because of 3 directions. You will be flying one aircraft only. You have 3 directions. A direction will be measured clockwise from the reference. So let's see what is the magnetic heading. You measure magnetic heading from magnetic north. Up to this. How much are you getting, students? What is the value?
310.
Yeah, Sordeep?
310.
310.
Everyone. It is lesser than true by 5 degrees, 310. And we can actually see the pizza pie is a smaller one compared to true north. That's the relevance. So 315 true, and the magnetic heading would be 310M. The third element, if deviation is 6 degrees west, it means the compass north. is 6 degrees west of true north. 6 degrees west. Here is your compass north. So what is the value? You already know deviation west, compass best. Here also you can see if I am making the angular measurement in green, I am getting the maximum, highest between the three. The circle is longer because the starting point is gone to that side. What is the value, students? My compass direction. Yes. Deviation west, compass best. Compass best with respect to magnetic. By how much value? 6 degrees. With respect to magnetic, students, not the true. With respect to magnetic. Remember. Students, with respect to magnetic, what is the value? Give me your answer quickly. We are running short of time.
316.
Achal, Jyotsna, check your answers. Deviation with respect to magnetic, not true. So deviation west, compass best with respect to magnetic. Magnetic is 310, 6 degrees west. We will add. So I will get 316 compass like this. So my compass will show me 316. My actual magnetic heading would be 310. And I'll be actually tracking a track of a true direction 315 true. Who's confused? Anyone confused? Utkarsh, use the letter Charlie. It shows compass heading, right? Don't write west. Deviation is west.
Affirm, sir.
Always mention the relevant letter. So one aircraft will have 3 different headings. True heading, magnetic heading, compass heading, measured from their relevant reference. True north, magnetic north, compass north. And the same relationship for your numericals that I'm going to give you to practice will be written like this. C, D, M, V, T. T will be 315. Variation is 5 degrees east. Also remember, plus symbol will be east. Sordip, correct answer. Magnetic will be blank. Deviation will be 6 degrees west. Compass will be blank. You will be required to fill in the blank. Simple as that. Got it, everyone? Any questions or any doubts? Make sure you remember how to sketch it. You might forget it. There might be certain confusions. So the next session, I'll start with a revision of this before I talk about the wind velocity triangle. And before we start with wind velocity triangle in the next class, we'll be revising this and we'll be solving your doubts. So make sure you are fulfilling your assignment by then. Okay. And the assignment is to practice the numericals you will get via email sometime today. And you'll email me your answers. A subject line, navigation assignment. Simple as that. Got it, everyone? Any doubts, any feedbacks, anything that we can improve, drop me a message. I'm already 4 minutes above. I don't want to stretch it further. So if you have anything, let me know. And please do a mental revision by yourself sometime during the day. Also do a revision of your notes sometime during tomorrow. And be ready for the class on Friday. We'll be learning a lot. Okay. With every class, you will develop your appetite of learning more and more and more. All right, students. So I'll be taking your leave. We are not doing a class revision right now, but let me know your doubts and your questions. And on YouTube, if you want to revise these lectures, they will be under CPL Air Navigation Batch Foxtrot 22 as a playlist. Whoever needs it initially, I'll share it with you. And I'll be restricting it to your registered email IDs so that only you can watch it. If for some reason you are unable to access it, let me know and I'll give you access. All right, students? Okay, thank you for being a good class and very happy to see you giving me 3 hours on your first class of navigation. That is excellent. You gave me a good vibe to stretch. Otherwise, I would have ended in 2 hours. I was just checking how the class is taking it. Well done. Not every time will we have 3 hours. But if we do have a maximum session, that will be of 3 hours. So today you have experienced the tough scenario. Okay. Don't worry. Sometimes we'll have 1.5 hour also. Okay. Depending upon the topic. So I'll see you on Friday, same time. Until then, follow the instructions and make sure once you get the assignment, sit in your free time, solve. If you have any doubts while solving, let me know, call me or text me, and finish the assignment and be ready for the next. The next will be given to you on Friday and you'll have a lot of time to complete that. All right. Bye, everyone. Signing off. Thank you for being a nice class and see you. See you when I see you. Take care, everyone.
Thank you, sir.
Most welcome. Most welcome, everyone.
Thank you, sir.
Most welcome.
Thank you, sir.
Most welcome.